Hi, Math 2. I'm going to be going over the practice 4 problems, some helpful hints for you to complete them. And then if you have additional questions, please bring them to our Zoom office hours or send me an email. So in the first problem, it talks about matching the description with its equation. So they're describing a circle. They're giving us a center and a radius. So we're going to need to use our formula. We're going to have to memorize this formula, but it's helpful. It's on my formula sheet. X minus h squared plus y minus k squared equals r squared, where hk is my center and r is my radius. So let's take a look at B. So B tells me that my center is 1, -4. So this is my h and this is my k. So when I insert those into my formula, I have x minus h. So since h is +1, when I plug it into my formula, it looks like x minus 1 squared plus y minus k. Well, k is -4 squared. And a negative is a positive, so I need to change that. It's really just y plus 4, and you're welcome just to write y plus 4. You don't need to do the two negatives and cancel. Equals, and now this one seems tricky. It equals r squared, and if my radius is the square root of 3, let me write that. I want to square the square root of 3. In other words, I want to do the square root of 3 times the square root of 3. So let's just think about that off to the side for a moment, shall we? The square root of 3 times the square root of 3. These are like terms. They're both square roots. I can multiply them, and I get the square root of 3 times 3, or 9. And the square root of 9 would be what, ladies and gentlemen? 3. My squared and my square root canceled to 3. So the actual answer to this problem would be x minus 1 squared plus y plus 4 squared equals 3. So then I look at my choices, and it looks like that would be number 5. So it looks like B goes with number 5. So give these others a try and check your answers, of course, in the locker. So number 2, it says write an equation of a circle that's centered here with a radius of 5. So we've just talked about how to do that using our circle equation. We're going to insert our center, and then we're going to square our radius. So let's take a look at 3. 3 has wrote our circle equations in an interesting way. You don't really see an h and a k here, so sometimes students are confused. Let's pull this guy off to the side over here. X squared plus y squared equals 4. So they're looking for an x minus h and a y minus a k. So I want to point out that when you see it in this form, another way to think about this is x minus 0 squared and y minus 0 squared is equal to 4. That's what they mean when they say, because x minus 0 is just x. So in this case, when I see this, I know that my center is 0, 0. And now be careful. This is where some kids are going too fast. This is r squared. It is x minus h squared plus y minus k squared equals r squared. So really, my radius is the square root of this number. The square root of 4 is actually 2. So if this is r squared, then r would be 2. To draw that, my center is 0, 0. And when you draw a circle for me, I need to see 4 points. I need you to take the radius, in this case it's 2, and I need you to go up to, vertically up to, I need you to go right to, I need you to go left to, I need you to go to down to, and then you're going to softly connect those points. If you happen to have graph paper or can print out graph paper, you are welcome to do that for this activity. So now you're going to have to do this problem on your own. So the next one I want you to graph is x squared plus y squared equals 1. Same idea. You're going to get your center. Your 1 is your r squared, so you have to think about the square root of 1 for your radius, and you're going to draw it. And then think about this transformation. Your blue circle would be the original one. And what would happen to your blue circle if you shrank it or dilated it by a half? And then what do you notice about the two circles you should have on your graph? Check that out in the locker and bring questions to Zoom. So then, ladies and gentlemen, let's take a look at the next problem. This problem, number 4, says that this is an example of a transformation, okay? It's called a glide reflection. Complete the table using the rule, and then does it produce a triangle that's congruent? So I would recommend, this is my xy column. This is my x minus 3. Ooh, careful, 4 minus y. That looks interesting. So let's do this first one together. So my first term is 6 minus 3, which would be 3. My second term is 4 minus 1. 4 minus 1 would be 3. Looks like it's 3, 3. So ladies and gentlemen, my recommendation, do the next one. And then when it says to produce a congruent triangle, maybe you want to lightly sketch out the graph. Graph these 3 coordinates and connect them. Graph these 3 coordinates and connect them. And are you looking at congruent triangles? Is that what this did? Okay, ladies and gentlemen, number 5, if you read it carefully and you look at your rule carefully, you should be able to answer this one based on our previous lessons. Number 5, we've done prior to this also. So let's just take a look at one or two of them. For example, let's take a look at F. My transformation is taking xy to x and y minus 3. I know this is a translation. I know this is basically just going to glide around my graph. Basically, my x-coordinate's not going to change. My y-coordinate's going to go down 3. So if this was a triangle, it'd basically moving down 3 on my graph. So I'm looking for something that's telling me to take 3 away from my y term. So I look at 2, for instance. 0 and 0, so the x doesn't change, but the y value goes down by 3. So it looks to me like F and 2 would go together. And you guys can take a look at the others. So now 7. Oh, this is going back to our volume unit. Okay, a cone-shaped container is orientated with its circular base at the top. So I have this circular base at the top. This is my cone-shaped container. It says its apex is at the bottom. Remember, that's the point. That's my apex. It has a radius of 18. Okay, here's my radius of 18. And it has a height, okay, a height of 6. Well, I didn't draw mine to scale very well, so you need to pretend that this is drawn better. But this is my rough sketch of what's going on. No way would 6 actually be longer than 18, but we're going to just leave that for now. So it says the cone starts to fill up with water. So maybe you're pouring water into this. So my water is starting to rise from the bottom. It says what fraction of the volume of the cone is filled when the water reaches a height of 2 inches. So my water is flowing in, and at some point my water is at a height of 2 inches. So if this total cone, if this whole cone's height is 6, then I've got about 2 inches of water in it. This is like a snow cone. You're eating the snow cone. You get down to the very little bit of your flavoring, your syrup that's kind of at the bottom. So that's what we're talking about here. It wants to know what fraction is this area with this water. I'm going to shade it in. What fraction of the whole entire cone is that? So what I really would like to do is find out if I found the volume of the water, so the volume of my blue space, and I divided it by the total volume of the whole cone. That would tell me what portion, what fraction of this is water, and the rest is just empty. So this is actually using not only volume, but it's actually using similar triangles from a long time ago. So check out this. If I drew this 18 by 6 as just a triangle, Again, I'm going to draw it so it looks similar to the picture I have above, so please forgive the fact that it's not drawn to scale. But this entire distance is 6, and this little distance down here is 2. I don't know this distance. That's my nested similar triangles. I'm going to use a proportion. I'm going to write a proportion to solve for x. For example, we would say things like 2 over x is equal to, for example, 6 over 18. And we'd solve that and we'd find out this value. We'd find a number for that. That's really useful because if I knew this radius, if I knew this number, then I could use the 6 and the 18 to find the total volume of the big cone, because the cone's volume is 1/3 pi r squared h. So I know my r and I know my h. I can find the total volume. If I found this value, I could use that number and the 2. This is my radius, this is my height, and then I could find the volume of my water. And then I'm simply, and actually my water would kind of have a circular top to it, wouldn't it? And then I would divide those two numbers to find my fraction of the cone that's filled with water. The work is in the locker, and if you have questions, make sure you bring it to our Zoom office hours. Thank you so much.